All right, hey everybody. Thanks again for fighting through another tough problem set, mixture of kind of easier problems and it's probably way too hard problems. But anyways, the further you dig, the better you get, right? The more you understand, the more you're just like, okay, I want to hopefully work my way to keep track of everything here. So anyway, somebody put down here 18, 19. I don't understand. I actually talked to this group, went through number 18 with them. They said they got a lot better. I'm still going to film another video for number 19 because usually we explain that in class, right? This is usually one. It's always one like, just like only a few people are gonna get this one. Yes, only a few people get this one. So I know you always want to be that person, right? Who gets that one. I wanted to be there, but I was never that person, it seemed like in high school. But anyways, hopefully you find a way, right? And I don't know how people find this way, but they just realize what they're given isn't enough. Then let's see if we can be clever and figure out something else that we can make an argument for to get us there to what common external tangent, exterior tangent segment AB must be equal to. So external tangent segment. There we go. Try to finding that. Okay. Anyway, so I have it here on this diagram here. We got circles P and Q have radius. So I'm going to draw the radius in that are going to be particularly useful to us to solve this one here. And that's going to be this. Point of tangency is like right here. Point of tangency is right here. And what does this look like? They look pretty parallel to each other. They are parallel to each other because remember, a radius drawn to the point of tangency is perpendicular to the tangent segment or tangent line. Same thing this one here too, right? Because it's a radius, it's outer ends. It's going to be perpendicular to the tangent line here. So we have this, and so now like this is we had with this. So it's just here's something to point out here. I got parallel lines going on. I definitely have parallel lines. So in a plane, right? In a plane, if all three of these lines are coplanar and two of them are perpendicular to this third line, these two lines need to be parallel to each other. They just need to be. That's a theorem, okay? These are also technically same side interior angles cut by a transversal, and they're supplementary, right? 90 plus 90 is 180. So, right, you should be able to believe me that we could prove that these two lines are parallel to one another. So we have that. Let's maybe put in the lengths of these, and the radius of this is 2, as we're given up here for circle Q. Circle P, this is 6. I'm going to move it out here because I'm going to write some more over here in a second, okay? The key to this one, the thing, I don't know how people discover this. They just do. Well, earlier, problem number 18, they did this. They had you draw in the trapezoid, okay? So I'm going to draw in the whole trapezoid because that'll become useful to us or important to us in a second. This length here, we can figure out maybe this length here. This is a trapezoid. We talked about this. It's a quadrilateral where exactly one pair of sides are parallel to one another. So it's going to fit the definition of trapezoid. But anyways, we want to figure out, well, I can get this side here, can I? I can because check it out here. This is, right, it's going to have to be congruent to that. This is a radii, right? These are radii of circle P. So this is length 6. This is length 2. Lots going on in this problem. Lots going on here. This is length 2. So this here, this whole segment, segment PQ is length 8. Okay, and that might help us here. That might help us get B, okay? So you're thinking, how do I get B? How do I get B? What do I do? What do I see? What do I notice? Wait a second. We can do this. This is the key to the problem, is thinking that, you know what? I can draw in a perpendicular here, okay? And what shapes get created? It says shapes plural, because you might see one of them right away. If I draw my perpendicular through a point outside of a line, there is exactly one perpendicular that you can draw to a particular line. So for passing through line Q, this is one perpendicular that you could draw to line AP. And that's here. This is perpendicular. So what do I have? I have a right triangle and here, but what is up here? Well, of course, there's a right angle on that side, right? Because a perpendicular forms 4 right angles. So I have a perpendicular, I have a right angle there. Wait. I made those right. I forgot to, I said why they're right, because this is a tangent here, and it's perpendicular to its radius at its outer end, the point of tangency. So I have a right angle here, I have a right angle here, I have a right angle here. This is also a right angle, right? Because 90 plus 90 plus 90, right? 90 plus 90 is 180, plus 90 is 270. This is a quadrilateral up here, right? This is a quadrilateral up here, different quadrilateral than we were talking about at the beginning. This is a quadrilateral, and it has 360 degrees. Well, 90 plus 90 plus 90 is 270. 360 minus 270 is what? 90, that's also a right angle here. So I have a right triangle down here, and then I also have a rectangle. a rectangle up top here. So I don't know. 7 people figured this out in 7th block. I was highly impressed with that. That was freaking awesome. So anyways, one of these ones where somebody just drops some knowledge on us, drops the mic. Oh, hooray. This isn't going to appear on a test. This is too hard here. But anyways, you have a rectangle here. You have a right triangle. We can figure this out now. We can, okay? Because check it out. What do we know about rectangles? Well, it's a parallelogram, so it's opposite sides. Everything connects, right? Everything connects here. Opposite sides of a parallelogram are congruent. So that's 2. This whole here, AP is 6, but then AZ, let's call it, is 2. This is going to be 4. This is going to be 4 right here, okay? So now to get AB is going to be the same as the length of this perpendicular segment right here. So let's mark it X because look at that. This is going to be a right triangle right here. We have X is longer leg. And we can solve for that, right, using the Pythagorean theorem. And then if this is X, opposite sides of a parallelogram are congruent. So this is going to be X here too, okay? Longer leg, and then longer leg is in the rectangle. Well, longer leg is same length, right? Same length. Because of the theorem that opposite sides of a parallelogram are congruent to one another, okay? So we just got to solve for X, and then we're done with this problem here. Whoa, why didn't you tell me that ahead of time? Oh, because it's fun, man. It's fun trying to break it on this diagram. I know, solid 11 or 12 people out of like 70-something figured this out, which is pretty cool. So anyways, don't put too much pressure on yourselves here, man. This is just fun. Fun to be able to figure something like this out. It's no fun if I just told you exactly how to do it here. Okay, this equals 8 squared. Okay, so now I got x squared equals 8 squared minus 4 squared. Okay, I might as well start squaring those things. I'll get 8 squared is 64, 4 squared is 16, so I'm taking that away. And then I get x squared equaling 48. Okay, now I got to figure out, I got to do what we're practicing, simplifying square roots. Woo! Okay, so I'm going to square root both sides of this so I can isolate x. Okay, so I get x equals the square root of 48. Well, square root of 48 is the same. Well, we got to think of perfect squares that go into 48. 4 goes into 48 12 times. The problem is 4 also goes into 12, so we can do better than that. 16. 16 goes into 48 how many times? 3 times. Okay, so there it is. 16. So x equals 16, root 16 times 3, and we can root 16, can't we? We can take the square root of 16, and that equals 4. Okay, that equals 4. So my answer here is 4 root 3. And there we go. We did it. More math knowledge. This isn't really math. I mean, this is problem solving, persevering. Thank you for watching this video. Let me know if you have any questions. I will see you guys on Friday. Classroom exercises today. Maybe got to sit through a lecture. Oh, school, man, school. Problem set tomorrow. Just keep going. Okay. Yeah, we get there. A little over a month to go. Okay, a little over a month to go. Just bear with me. It's going to be better if we finish this rather than just be like, hey, we did nothing this year. Anyways, no, it's something we did nothing this year. Bye. Just bye. Bye.